Users tables have been around for decades. People have used them, whether they're rolling their own auth or using auth providers, for as long as I can remember. I remember back in 2008 looking at a users table, and I see them frequently when working at Clerk. But in 2023, you don't need a users table. Now, this is what a traditional application may look like, where you have a users table and you build relationships based upon a user ID or a first name or an email or whatever it might be that you're building relationships. In this example, I'm just using user ID that then is the author ID here in the post section, allowing me to build those relationships and retrieve all of the posts for this person with an author ID. Now, this would be a case for something like Nextauth, or maybe roll your own auth, whatever you're doing in a normal scenario. But once you leave the roll your own auth scenario and you pay an auth provider, or you use a free tier for an auth provider, like Clerk, for example, you can then delete this table completely. So if we scroll down here and look at an application with an auth provider, this user ID can be used anywhere in the stack, whether you're on the client, whether you're on the server, or if you're in middleware, you can do it there also. So this allows you to build these relationships. After sign up or they create their first post, you can insert this into the database and you can retrieve all of their posts upon it. Then if you have a multiple user scenario where maybe you need to retrieve all of those, you already have the user IDs and you just need to feed them to Clerk for any additional enrichment that you might need, like profile images or say first and last name for an author. But in some scenarios, this doesn't always work. There are scenarios where you may actually need something in your database to build out more of a relationship. And that's where tenant tables come in, which are very different than a users table. Looking back at the users table, it's basically every piece of information that you need to build your application. Things like last signed in, updated at, sign in at, was the user's email verified, etc., etc. So the users table is pretty rich with data. When you start to need a tenants table, it looks more like this, where maybe you have a user ID, maybe an organization ID if you're working in B2B, and then maybe some small pieces of information such as a profile image, things that are essential for you to build out very complex scenarios. Now, in most cases, people building applications will never ever have to be here, because at the end of the day, most people aren't building these incredibly complex systems that need this additional information. So what does this look like in the real world today? Could I show you an application that is using this, where they're not using a tenants table and they're just using a user ID and handling this? Well, I can show you how this works by using Theo's Chirp application tutorial, which you can check out in the corner. I'll put a link somewhere, where he is using Clerk and he's also using author ID to grab each and every individual tweet. So let's look at that and how it works, and I'll show you the code behind how he's using it to fill in those pieces of information and the minimal amount of latency that you get today. So this is Chirp. If you've not seen Chirp before, it's essentially like Twitter, but with emojis, and all these different people have their user ID and then an image which is based upon their GitHub profile. Now I've signed in here, and now obviously I can just grab these emojis and I can paste them in here and hit post, and then it's been posted. And if I reload the page, you can see how quick that was. And now my name is there with the images and everybody else's is there. And you can see how fast it is, even though there's hundreds and thousands of different posts here. We can now talk about the code itself. So if we go to GitHub, so now we're looking at this post routes. The first one we need to look at is this create. So what Theo is doing here is taking the content and making sure it's an emoji, and then using the context to grab the user ID, which is provided by Clerk. And then he goes ahead and inserts that into the database using Prisma and create. The same thing happens here when you get posts by ID. He is pulling in the author ID and then taking the first 100 and then sorting those as well. But the big piece here is that nowhere is he having to fetch stuff from a database for the user's details, such as the profile, name, username, etc. That is all being powered by Clerk. So as you can see in this get all, which is the one that loads all of the information from every single emoji, he has this add user data to posts. And what we're doing here is going ahead and calling Clerk and adding in any of the user details we might need. So in this case, he is pulling in the username, which is the user's details, as well as the author details that you already had from the original post. And this allows him to show you both the user details from Clerk in the rUsers table and also use this authors table. So for the final thing that people push against when I'm talking about user tables is cascade deleting, where you delete the user and then all of their subsequent data. But this works just the same whether you're using a auth provider or you're using a users table. When people often think about cascade deletes, what they think about is this user ID here on my users table or my accounts table or whatever table you're using holds that cascade delete. So when you delete it, everything that is attached to that user is then subsequently deleted. But it works the same way if you're using an auth provider, especially if you're using something like Clerk. So the user would ask, delete me and my data. So what would you do? So first you would make a request to the database and say, please delete all associated data in the post table and any other tables that are joined together, subscriptions or whatever else you may have with this user ID. If that delete my data fails, so if it fails, you don't do anything. So we already know that that's failed. Like for whatever reason, the DB has failed to delete their data from the database. You don't do anything. And then all you would do is, if it was successful, so if success, delete the user from Clerk. It would work exactly the same as if you were deleting your account via, say, a cascading delete for a users table. The idea is that you just shift that mentality slightly and think about how would you delete the data. Well, first you want to remove it from your DB where it's using that user ID, and then finally delete it from Clerk where the user can no longer log in and have any application data. So all you have to do is really shift that mental model from I need to have a cascade delete if I delete the user to I need to make a procedure to delete them from PlanetScale or wherever you're storing your data. And then finally, the last step is to delete the user. And if any data fails for whatever reason, don't delete the user from Clerk and let the user know. So what do you think? Should we drop a users table in 2023? I think so. If you did enjoy this video, click this one right here. We'll show you another one, algorithm driven. I don't decide what it is. And if you're not subscribed, why the hell not? You should be subscribed to my channel at this point.